graph f of x is equal to cube root of x minus 3. We can concentrate on graphing f of x is equal to cube root of x only. And this 3 would cause this graph to move down 3 units. We can use the shifting method to do this. So let's see how to graph this. We need some points here. If x is equal to 0, f of x, or we can call it y, would be equal to 0. Cube root of 0 is equal to 0. So we find 1 point. If x is equal to 1, then f of x or y would be cube root of 1, which is still going to be equal to 1. So my graph is going to pass it through point 1, 1. So we find this point here and this point here. If x is equal to minus 1, cube root of minus 1 would be equal to minus 1. So we found 3 points here. Now, if you want more points, what would be the best point to select here? What are you going to let x equal to what? 8. This is 8. Yeah, it makes sense because cube root of 8 is equal to what? 2. So if I let x equal to x here, then we have cube root of 8. I can write it as 2 times 2 times 2. You can clearly see that would be equal to 2. So we find another point. If x equal to 8, y is equal to 2. Now if I use minus 8, similarly, then cube root of, that would be minus 2 times minus 2 times minus 2 under the radical here. So that would be equal to negative 2. So I found my other point is equal to that. So you see, the graph gradually increases. If I look at my graph here, let's locate the points here. If x equal to 0, y is equal to 0 would be this point right here. If x equal to 1, y is equal to 1. So my graph going to pass through this point. It's negative 1, negative 1 here. Now, if x equal to 8, 1, 2, 3, 4, 5, 6, 7, 8. See, if x equal to 8 or minus 8, coming down here, coming down here, y would gradually go up to plus and minus 2. So if I graph this and then move this to 3 units down, that would be the graph that I'm looking at right now. So that same graph here is moved 3 units down. So this graph, right, and then, okay. So as you see, if I shift this graph here, the same graph here, if I shift it down 3 units, I get to this graph here. Okay. So if you didn't want to use the shifting method, you could use the same table here for cube root of x minus 3, and then set up your table. So in this case, you would say if x equal to 0, y or f of x still gonna not 0 anymore because it would be 0 minus 3, so it would be this point here minus 3. So that is how you shift down 3 units, and as you substitute the values for x, you see everything shift down 3 units. So I would really like this shifting method to remember f of x equal to cube root of x, and then if you have minus 3 here, that means you're going to shift this whole graph down 3 units. If this were plus 3, then you would shift the whole thing up 3 units. This shifting method works for functions like f of x is equal to square root of x. And then we're going to graph this, let's say minus 2. So I would I have to concentrate on f of x equal to the square root of x. If I set up my points here, if x equal to 0, y or f of x would be equal to 0. So my graph going to pass 2.00 at one point here. If x equal to 1, y would be equal to square root of 1, which is equal to 1. So I'll find another point 1, 1. Now as I increase the value of x, as you see, f of x would gradually increases. So what would be a good point to select here for x, anyone? 4, right? Very good, 4. So it means because square root of 4, I can easily find is equal to perfectly squared is equal to 2. So that would be if x equal to 4, y would be equal to 2. But I cannot substitute any negative numbers here because remember the square root of negative 1 is a complex number, is an imaginary number. You recall? So my graph only going to cover the positive x. The domain starts from 0, 0. It cannot go below that. So as you see, if x equal to 0, y is equal to 0. If x equal to 1, y is equal to 1, right here. If x equal to 4, 1, 2, 3, 4, just gradually go up. That would be 2 right there. So you see graph gradually go that way. Now this would be graph of y is equal to square root of x. Now if I shift this 2 units down, that would be the graph of y is equal to square root of, this is a rough graph of that. If I shift that 2 units up, again the points are not exactly, but I'm just showing you like that same graph moves up. This is 2 here plus 2. The shifting method also works when you add the number inside the function. So if I were going to shift the graph to the right, okay, if this graph shifts to the right, let's say 1, 2, 3, 4 units. If I shift this graph to the right 4 units, here, this would be y is equal to square root of x minus 4. If I shift the graph 2 units to the right, this would be y is equal to square root of x plus 2. What you have to remember is, if it shifts to the right, this would be minus. This minus is part of the formula. That's why it appears to be opposite of the way we are moving. But here really is we're moving 4 units to the right. And then here, since this is part of the formula, this would be really is x minus 2. So we are moving 2 units to the left. That's why this would be x plus 2. So if the number add inside the function, that would cause the graph move to the right or left. If the number, the constant add outside this function, that would cause the graph go up or down. So if we have a combination of those two, if I have a if I have a graph somewhere on here, then it would shift to the right and also shift up accordingly. So if I were going to wanted to know what the graph of equation of this graph would look like, I can make one up right now. So if I say, all right, I want to know if I shift 2 units to the right and 3 units up, and I'm going to copy this graph here the best I can. This would be the equation of this, then would be equal to f of x or y, f of x or y would be equal to square root of x would be minus 2 because I'm moving 2 units to the right. It would be minus inside the function. And then because I'm moving 3 units up, then this would be plus 3. So that would be a shifting to the right and up at the same time. And this also works with cube root or parabola or straight line, the shifting method would be pretty handy way to graph your functions.